The team determined different hazards for the rider, including road conditions, visibility, and the vehicle itself. To protect the rider, riders will be wearing helmets. Rear view mirrors will be mounted on the fairing, and the vehicle itself has trim around it to protect against sharp edges, as well as all of the frame is deburred and sanded to get rid of any sharp edges. To also protect the rider will be in a 4-point harness. They will also have an RPS around them to protect during rollover. Their feet will also be protected by the front mount derailleur. Sound engineering principles were used to design the frame for safety in mind. FEA and an iterative design process ensures that the RPS will be structurally sound during a flip over. To protect the bystanders, the bike will have a tail light, a headlight, and a bell. The headlight and tail light will be automated with our additional safety feature. When manufacturing the bike, the team was as safe as possible. We used protective equipment during grinding and sanding. Safety glasses were used at all times in the lab. When welding, we had protective equipment for our face, eyes, and hands. Also during loud equipment noise, we had hearing protection on. One other safety feature in the lab is knowing which tool to use and how to use it correctly. For example, when cutting holes into our frame with a hole saw cutter, we ensured we knew the material and cutting speed necessary to be safe when doing so.
Our additional safety feature is a proximity activated light system. So what will happen is we have our headlight and our tail light mounted on the vehicle, proximity sensor located behind the driver, and when they sit down, then it'll activate the lights. When they get off, then it'll turn off the lights. So this ensures that lights are always on when the rider's on the vehicle. Additionally, we have LED strips which will be mounted on the fairing for high visibility at night. So these will be activated by a switch for the rider, and these will be along the side of our fairing.
Another safety design feature is the stability of the steering system. The team did not want a system that had high turning fluctuations with small linear movement. Instead, an appropriate amount of linear travel is needed for an appropriate turn radius. Another potential safety hazard for the rider is the chain falling off of components. To help mitigate that hazard, chain guards were put on the idler pulleys. Another design consideration for the frame is the bending of aluminum tubes. If the bent tubes crumple, the structural integrity decreases. To prevent this failure, the tubes were annealed to an O-tempered state and then after bending, heat treated back to a T6 state. All bolts and fasteners on the frame were tightened and then locked in place using Loctite to ensure they would not come loose during the competition or during any time the bike is in operation.